This example comes out of 2.4, the product rule. The way that I wrote the product rule in the last lesson was like this. F times g prime is equal to fg prime plus f prime g. Sometimes you'll also see it as, the derivative of f of x times g of x by dx equals f of x times the derivative of g of x plus g of x times the derivative of f of x. Obviously a much more tedious notation, more writing involved. But let's try this for an actual example. If we're asked to differentiate y equals 3x to the 4 plus 1 times 2x cubed minus x. Let's find dy by dx. Because this is early in chapter 2 and we haven't used or learned how to use some of our more complicated differentiation rules later coming up, like the quotient rule and the chain rule and some of these things, right now it's not immediately obvious why you'd even need a product rule, because really I could expand this thing and take the derivative of all the pieces and get an acceptable answer. But let's practice using the product rule, and I promise, coming soon, you will see more of a reason for it once the functions get a bit more complicated. But for this one, we're going to say, okay, well, let's take the first function, 3x to the 4 plus 1, times the derivative of the second, so that's going to be 6x squared minus 1, plus the second function without changing it, times the derivative of the first, which is 12x to the 3. I can do a little bit of tidying up by multiplying the factors together and combining my like terms. So I've got 18x to the 6 minus 3x to the 4 plus 6x squared minus 1 plus 24x to the 6 minus 12x to the 4. So my derivative equals, I've got 42x to the 6th, I've got minus 15x to the 4 plus 6x squared minus 1 is the derivative of that function. Similar in difficulty really to having expanded it first and then differentiating it. So again, until we learn some of the more complicated chain rule, quotient rule, right now you have some options how you would do these. So let me give you another one. We're asked to differentiate and simplify this function, f of x equals square root of x times 5 minus 4x. Again, let's use the product rule to do this. So I've got the first function, root x, times the derivative of the second, which is only negative 4, plus the second function times the derivative of the first, which is 1/2 x to the negative 1/2. Now, that's an answer. You would probably be best advised to do a bit of work after that, since the question said simplify. I've got negative 4 root x, or negative 4x to the 1/2 if you prefer, plus 5 over 2x to the negative 1/2, and then minus 2x to the 1/2. You can see why simplifying is useful here, in that we've got some like terms. So I've got negative 6x to the 1/2 plus 5 over 2x to the negative 1/2. Now, in some situations you'd be okay to stop right there. Realistically, coming later on, it's going to be very, very important that we can factor this and make this look a little bit neater and tidier so we can find some more answers and things from it. So I would probably suggest taking out a negative 1/2 x to the negative 1/2, because then let's take a look at what I have left. Well, I'm going to have 12x and then minus 5 in my brackets. That becomes especially useful, having it factored and written in that form later when we're trying to find when would this equal 0 and to find important values, critical numbers on the graph and things that come in some later chapters. So for now, you have to take my word for it, but practice factoring and simplifying your derivatives as much as you possibly can.